Welcome to the presentation of the paper Preventing Technical Debt by Technical Debt-Aware Project Management. This paper evaluates a framework that was developed in industry by a unit in the company Gruner & Jahr GmbH. The unit manager of this unit is Julian Schwarze, who is also my co-author. The framework was evaluated by the University of Hamburg by me and my co-author Matthias Riebisch. I will first introduce the case company, or rather the unit of this case company, and their technical debt-related problems with a problem statement. After that, I will introduce the framework which they invented to tackle these problems, and I will finish with the evaluation and the evaluation results, and in the end I will show you the key takeaways from this paper. Gruner & Jahr is one of Germany's largest publishing houses. They started mainly by publishing magazines, but due to digitalization, they also published their content on websites and finally in mobile apps. They became one of Germany's most successful online and mobile marketers for selling advertisements. So their main competitors are Google and Facebook. This naturally leads to a great market pressure and therefore to tight timelines for the IT systems. For their IT systems, that meant not only tight timelines, but also frequently changing systems. The systems had to change due to new advertising formats. The people that are working in advertising are quite creative. They are creative in inventing new advertising formats, but also in using and misusing the IT systems to make new advertising formats possible. And we also observed a merging of the German companies so that they get a bigger market share in the advertising market. And this also led to the problem that the IT systems had to be merged. As a result, technical debt accumulated, and we had some consequences like increasing cycle times. So every estimation was discussed and negotiated, and it was always the question, how can we get this faster? And we had more defective systems. So especially after deployments, we had some bugs in the systems. And we observed discontent of developers. The developers wanted to produce good software, but they didn't get the time to do this. And this also led to hard-fought discussions between project management or business analysts and developers. And finally, we had a surprise management because the management weren't even aware that they had taken on any technical debt or any debt at all. And so they were quite surprised about the amount of technical debt that they obviously had accumulated. To tackle this problem, this IT unit developed a framework, and they identified 4 categories of tasks or to-dos in the daily work and the respective rules for recording, processing, and the responsible persons. The first, they identified maintenance tasks, which are, for example, regular refactorings, but also the adaptation of the system to a new environment. For example, if the API of a system changes, of an external system, then they had to adapt to this change. This also comprises the repayment of unintentionally taken technical debt. The second is maintenance projects. Maintenance projects are maintenance tasks that take more than 5 person days on time, or that need coordination between teams and is therefore kind of a bigger task. This is both not new. It is already mentioned in the white paper of Steve McConnell. What is new is the focus on intentionally taken on technical debt, and I will introduce this in a minute. Finally, they identified deconstruction tasks. These are tasks to delete code fragments that were necessary at one point in time, but are no more necessary now. I will now present the idea of technical debt tickets. Technical debt tickets comprise tasks that would be part of the implementation of a functional ticket if this functional ticket would be done in an optimal way. but in an estimation meeting there may be the discussion how to save time to reach a certain deadline. And to save development time, there may also be another implementation option, which is suboptimal but maybe faster to implement. We interpret here the technical debt as the difference between this optimal and the suboptimal solution. And we have the opportunity to decide if we want to implement a suboptimal solution and create a ticket for this, and also to create a ticket for this technical debt to reach the optimal solution, or if we just have one ticket to implement the optimal solution. This decision usually depends on the time in terms of effort it takes for to implement the optimal or the suboptimal solution, and the time pressure of the project. These decisions are usually made in the estimation meetings that are part of the main development phase. Usually a project ends after the deployment deadline is reached, or shortly after an initial use phase. What is new with this framework is that after this initial use phase, the technical debt that was accumulated in this main development phase have now to be repaid as part of the project before the project ends. So the team and the project manager kind of becomes responsible to clean up after themselves. By this is not only technical debt is repaid timely, but it is also it also generates a feedback loop of team behavior. So the team and also the business analyst or project manager are more willing to implement the optimal solution and are less willing to create technical debt or to accumulate technical debt. And it especially becomes a more conscious decision in this beginning to take on technical debt. For the evaluation of this framework, we first evaluated ticket statistic. The ticket statistics of technical debt tickets and maintenance tickets. The green line shows the accumulation of technical debt and the creation of technical debt tickets. The yellow line shows how these tickets are processed. The gray dotted line in the middle shows a project deadline we had in April 19. We here can observe an increase in the green line, and so the accumulation of technical debt. And by the increase after the project deadline of the yellow line, we can see that technical debts are processed after the deadline. We can find corresponding lines in the maintenance tickets, and which shows that also maintenance tickets were delayed because of this project deadline. This especially shows that the framework is working in general. To evaluate the effects of the feedback loop, we conducted a survey in the unit that uses this framework, the observed unit, and in a comparison unit. The comparison unit was smaller, which is a threat to validity, but they had the same unit manager, and therefore they had a similar organization structure. For example, in both units, the business analysts were also project manager and were also acting as a product owner in terms of a Scrum organization. The response rate was at 50%, and it was a little higher for the comparison unit. In the survey, we asked the participants if they usually compare different solution options before they start the implementation. And we observed obviously very different behavior between the two units here. 75% of the observed unit usually compare different solution options before the implementation, while only 20% of the comparison unit did this. We also asked them if they were calculating or rather estimating different cost aspects of these solution options, and we found similar results. Most of, or at least for principal and interest, some of the observed IT unit were doing this, while nearly none of the comparison unit did this. We therefore asked the participants what benefits they saw, or in case of the comparison unit, expected by comparing different solution options. And we can see that they expected or saw more rational decisions, more rational discussions, especially, and they both saw that technical debt can be prevented by this. We finally asked them if the effort for this comparison, which obviously takes time, is justified by these benefits. And we see a great approval rate here. The key takeaways from this paper are that technical debt-aware project management, which makes the project manager and the team responsible for the accumulated technical debt of their project, creates a feedback loop in team behavior. This leads to more rational discussions and more rational decisions, and technical debts are taken on more conscious and intentional by comparing different solution options. Finally, this can lead to the prevention of unnecessary technical debt. In the end, I want to thank my co-authors, the Gruner und Jahr GmbH and their units, for their participation in this study. And also I want to thank you for listening, and I'm now looking forward to the discussion. Thank you.
Hello, I'm Marian, and hello.
Hi, everyone. Yes, can you hear me? Okay,
Yes.
so everyone, welcome to the second session of Tech Debt. We have our second paper here, and the paper is entitled Preventing Technical Debt by Technical Debt-Aware Project Management. And the paper will be presented by Marion Weiss from the University of Hamburg. So you can start, Marion. You have 15 minutes for your presentation, and then we have questions. Once again, if anybody has questions, please write them in the chat, and I will ask them at the end of the presentation. So I will leave the stage to you. Go ahead.
Okay. Yeah, hello. I'm Marian, and I will present the paper Preventing Technical Debt by Technical Debt-Aware Project Management. This is a paper about an evaluation of a framework for managing technical debt that was developed in an industry environment by the unit by a unit in the company of Gruner und Jahr GmbH in Hamburg. And the unit manager is also my co-author, Julian Schwarze, and the framework was then evaluated by me and my co-author, Matthias Riebisch, in the University of Hamburg. I will first introduce the case company and tell something about the technical debt-related problems they had and they were facing. And after this, I will introduce the framework they developed to tackle these problems, and will finish with the evaluation and the results of the evaluation and the key takeaways from this paper. Gruner und Jahr is one of Germany's biggest publishing houses. They started mainly by publishing their content in magazines, but due to digitalization, they also had to start to publish their content on websites and finally also on mobile apps. So, and by this, they became one of Germany's biggest online and mobile marketers. So they were selling advertisements, and therefore their main competitors were companies like Google and Facebook. So that led to a big pressure to get in time to the market, and also led to always great time pressures for the IT systems. The problems were not only the tight timelines, but also frequently changes to the systems due to advertising formats. The people that are working in advertising, they are quite creative people, and so they are not only creative in developing new advertising formats, but also in using and misusing the systems we provided. And the second effect that took place were merging of companies to get a bigger market share to compete with the big players from the US. And this led to also tight and very stringent timelines that were usually related to the business year. And as a result, this led to technical debt, as we all know it. And we had to face the consequences, which were increasing cycle times and especially hard-fought discussions between business analysts and developers and negotiations about every ticket estimation. We had defective systems, especially after deployments. We had lots of bugs. And we also observed the discontent of developers, which you may know as a developer moral problem. So the developers wanted to produce good software, but they usually didn't get the time to do this like they wanted to. And that also led to many hard-fought discussions. And finally, we had surprised management. That means the management wasn't aware that they had taken on any debt. They knew this notion of financial debt, and the manager was like, "Okay, but I didn't take on any debt, so why do I have debt now?" So they created a task force to tackle this problem, and they identified 4 categories and their response, the respective recordings and processing rules, and they identified the responsible person for these categories of tasks or to-dos. And these tasks were recorded in a corresponding tickets in a backlog. And they first identified maintenance tasks that comprise regular refactorings, repayment of unintentional technical debt, and the adaptation of systems. For example, if an API is changing of a library they were using, they had to adapt to this. They also had this category of maintenance project, which is the same as maintenance task, but just bigger. So everything that needed more than 5 person days of time or that needed coordination between different days. And this is both not new. We have it, for example, mentioned in the white paper of Steve McConnell. But what is new to this framework is the managing of technical debt tickets. And I will introduce this in a minute. They identified a 4th category that are the deconstruction tickets that are usually tickets that for the deletion of code fragments, especially if we had like changing business rules, and the business rules changed with the business year. So we had the switches in the program where it says, okay, if you are in the old, if it's still the old business year, use the old rule. If it's a new business year, use the new rule. And over the time, we had a lot of these switches in the program, and we started to have these deconstruction tasks to tackle this problem also. I will now present the idea of the technical debt ticket, which is the main contribution for this paper. Technical debt tickets comprise tasks that would be part of the development of the functional ticket if this development would be done in an optimal way. But in estimation meetings, there were maybe discussions about how to save time to get to reach a timeline. And then the discussion would go on, and to save development time, there may also be another implementation, like a suboptimal implementation, but which is faster to implement. And so for this framework, we interpret technical debt as the difference between this optimal and the suboptimal solution. That led to the decision to either record 1 ticket for the optimal solution, or to record 2 tickets, which comprise the suboptimal solution to reach the timeline, and also already to record a ticket for the technical debt repayment. And this decision, if whether the one or the second solution, would be made usually depends on the effort that it takes for the optimal and suboptimal solution, and obviously on the timeline pressure. So the decisions that these decisions were usually made in the main deployment phase of a project, and a project usually then has the main deployment deadline, and usually a project ends after this deadline or after this small initial use phase. And what is now new is that subsequent technical debt repayment phase is included in the project, and the project only ends after the technical debt that was accumulated in the main development phase is repaid. And this means that not only the technical debt is repaid timely, but this also led to a feedback loop in team behavior. That means the team was responsible for kind of clean up after themselves, and so they were not as willing to accumulate technical debt in the first hand. And it therefore became a more conscious decision to really take on technical debt, and a more conscious decision to maybe not take on technical debt. So we evaluated this by first looking at the ticket statistics for maintenance tickets and technical debt tickets. The green line shows how many tickets are created. The yellow line shows how many tickets are processed. And the gray dotted line here is a project deadline that was in April 19. And we can observe the increase of the green line, which means technical debt tickets were created and technical debt was taken on. And after the deadline, we can see that the yellow line increases, which means technical debt tickets are repaid. And we can see corresponding lines in the maintenance tickets, as we also were willing to stop doing this maintenance tickets during this time. So this shows that the framework works in principle. To evaluate the feedbacks of the effects of this feedback loop, we conducted a survey in the unit that used the framework and also in a comparison unit. The comparison unit was smaller, which is a threat to validity, but it was led by the same unit director. So this means that we had a similar organization structure. For example, the business analysts were in both units also responsible for the project management, and they were also acting as product owner in terms of the Scrum organization. Yeah, and we had a response rate of about 50%. In the survey, we asked the participants if they usually compare different solution options before they start the implementation. And we observed a very obvious, very different behavior between the two units. It means while the observed unit, so the unit that used the framework, said with 75% that they would compare different solution options before starting the implementation, only 20% of the comparison unit did this. And we also asked them if they were calculating or better estimating different cost aspects of these options, like implementation, principal, and interest costs. And we found similar results. That means it was done by many, or in terms of principal and interest, at least by some of the members of the observed unit, but it was nearly not done by the comparison unit. We further asked them what benefits they saw, or in case of the comparison unit, they expected when comparing the different solution options. And we can see that they observed more rational discussions, and that they were led more rational, and that also the decisions were made more rational. And finally, both units expected or saw, in case of the observed unit, that technical debt could actually be prevented by this. We then also finally asked them if the effort for the comparison, which obviously takes time, is justified by the benefits, and we observed also a great approval rate here. So I finish with the key takeaways, which means the technical debt-aware project management, which makes the project manager and the team responsible for the accumulated technical debt of their own problem, creates a feedback loop in the team behavior, and this benefits in more rational discussions, more rational decisions, and especially in conscious and intentional contraction of technical debt. And finally, this can lead to the prevention of unnecessary technical debt. I want to thank my co-authors, the Grun und Jahr GmbH units, for their participations, and I want to thank you for listening, and I'm now looking forward to the discussion. Thank you.
Okay, thank you very much, Marian, for your presentation of questions. So Florian asks, what time frames were talking about? And so is it referring to days, weeks, or months?
Let me go to this.
Slide 7, yes.
7. You mean the projects were usually like about 2 or 3 months. So we had a Scrum organization with 14 days Scrum cycles, but which also means shows in these pre-deployments we had, but usually the main deployments were like every 2 or 3 months, which especially was because the customers didn't want the systems to change more frequently.
Okay, thank you. And we have a second question. Let me just check if we have time. Yes, we have plenty of time. So we have another question from Alexander. Thank you for your answer, first of all. Second question from Alexander. He asks, do you have any estimate for the average time for handling a technical debt ticket? So, for example, to repay the debt.
That really depended on the debt. So we had like a small, so I don't really have the estimates at hand. So, but the small things, the advantage of this framework is that if it's only a small technical debt, it usually led to the prevention of this technical debt. So if they saw, okay, there's only a small effort to have for preventing this technical debt, they were willing to prevent it actually and have a little bit more effort in the first phase here. So here it was more the bigger technical debt where it was more reasonable to actually take on the technical debt at all. But I don't know. So it was like usually it was less than what can be done in one sprint.
Okay, thank you. Thank you for your answer. We have time for one other quick question. Tushar asks, would you like to elaborate about TD ticket prioritization meeting? Do you think it can be automated to some extent?
I think in this environment, it couldn't be automated actually, because there were too many stakeholders that were necessary here. We usually did it, we had like 2 prioritization meetings because also some functional requirements were delayed for after this line, this main deployment line. And it was like, okay, the business analysts, they had their priorities, and the architects and developers did their priorities of the technical debt tickets. And then we just made it like, okay, one technical debt ticket, one requirement ticket, next technical debt ticket, next requirement ticket. And as you can also see in the evaluation, it's also a problem of this framework still, is that not all technical debt can be actually repaid at all. So it was the repayment of the most pressing technical debts. and that already led to this more to this effects that I mentioned.
Okay, so thank you very much. We have less than a minute left. I'm just going to ask you a quick, very curiosity question. So how did the team perceive the introduction of the ticketing of tech debt tickets? So was it something that they liked, that they agreed to, did they do it only for the study? What was their general perception?
Yes, it's quite interesting because they really liked the idea, but the moral was so much down at this time that they were saying, so, okay, we can do this, but I don't think it will work, because there will always be this functional ticket which will be higher prioritized, and that can't work, and the next project will come and we don't have enough time. And so they wanted it to become real and they wanted it to work, but they had this expectation that it wouldn't work. But
okay.
So it was really good for them also to do this evaluation, because they also got this information. So
okay.
you can see
here. I have to cut you off.
Sorry.
Thank you very much. Yeah, sorry. This is so interesting. So whoever's interested, we can continue into the breakout room where we can continue the conversation. So there's Abdullah that would like to ask a question. You can ask it in the breakout room. I would like to thank everybody for your attention. Thank you for the interesting questions. And you can all join the discussion room for this paper. Zadia also added a link. So thank you, everyone, and have a nice rest of the remaining part of the conference. Thank you again. Thank you, Marian.
Thank you.